So I'll be doing problem 14 from chapter 19, and the problem reads: an electron and a proton are initially very far apart, effectively an infinite distance apart. They are then brought together to form a hydrogen atom, in which the electron orbits the proton at an average distance of 5.29 times 10 to the negative 11 meters. What is the electric potential energy final minus the electric potential energy initial, which is the change in the electric potential energy? So, to solve the problem, I first wrote down what was given in the equation. Here you have the distance between the two, or the radius of the orbit for the electron and the proton. There you have the charge, the respective charges of the electron and the proton, and here you have the necessary equation that we used in this problem, and here you have just ultimately what we're solving for. So the first step I did was to solve for the initial values of the the initial energies, or the initial voltages rather, of the proton and electron respectively, and this problem said that for our uses that we could assume that both of these were an infinite distance apart. So you could put, for as far as the distance was concerned, you could assume that it was infinity, and both of these over infinity would approach zero. So you know your electric potential energy initial would be zero. Next step we did was to do the same thing for the proton and the electron once you brought them together, and you found that using that equation, in which you were to use the absolute value of the charge Q, you found that they were actually equal, and they both came out to be 27.2 volts. So to find the final voltage, all you necessarily did when they were together, you simply just added them together and get 54.4 volts. And to finally solve for the electric potential energy final, since we know that the electric potential energy initial is zero, we simply just use this equation here, and we multiply our solve for voltage by the charge Q, which we know is 1.60 times 10 to the negative 19 coulombs, and we get a final answer for our electric potential energy of 8.7 times 10 to the negative 18 joules.